smallest KMP. Chef has stringers. P. But that was 1 to 4. So he is willing to reorder the characters of S. Basically, any anagram of S in such a way that P occurs in the resulting string as a substring. Okay, so basically, like from S, chef has characters, rearrange it so that you can generate a P. Remaining, there might be some other characters. Since the problem was too hard, decided to ask you, genius, right? Genius. Can you find the lexicographic smallest anagram of this? That P is substring. Okay, lexicographically smallest. L- That means alphabetically smallest. Okay, this is just a definition of substring, I guess. Yeah. Yeah. Test cases follows. So we have just two strings S and P. Output the smallest anagram of S, lexicographic smallest, I guess, that contains P. 10 to the of 5. So we might expect a solution of like what? N, like if I say this is a n, so n or n log n max, not more than that. Um, Interesting. Time limit is there once again. So most likely a linear solution. Oh, interesting. So it contains just English letters lowercase, so A to Z, that's it. We can actually store the character frequency. That might help. Yeah, this is just a previous solution, so let me just remove that. So I'm just kind of observing the problem statement over here with some test cases. So let me break down my patterns in two different test cases. So one is, let us say there exists just a single. Okay, let's come to that later on. So first, I'm taking some random P, right? P is the pattern. Yeah. So let's say P is equal to what? B, K, L, whatever. And S should contains these characters. They did have a, yeah, contains at least one of the anagrams contains T. So I'm not really talking like these characters are present at least once. Apart from that, maybe let's say what A. If we have A's, we would add it before this. If we have B's, would we add B over here or B at the end? Interesting. Okay, let's skip adding the first character, whatever we have of the pattern. Let's other character. So, like what I'm kind of trying to observed over here was, let's say I had some particular string, whatever, ZZZ. I can just remove the characters for this particular substring. So kind of like remaining string is what about less than this, just this. And if I talk about just like kind of arranging this, so ordered remaining would be something like what? A. Let's add a few B's as well. B and maybe C's as well. Like I think I will explain a little bit about this. So then BB, then CCC, then DDDG. Yeah, something like that. So ordered remaining will become something like this. This is the smallest which we can get if we skip this particular thing. Now, what we have to do is our ultimate solution should be smallest and contain this substring. So one of the possibilities like we can just add it at the end, we can add it at the beginning and so on. But we want to achieve the lexicographically smallest. So it has to do something with the first character. So if you compare these two strings, so for example this versus um, just a second, versus this one. Let me add it over what yeah. So if you look closely, like this has B and this is instead of C, so this will actually be lexicographically smallest, right? So, uh, and if again, like maybe one more thing, if B, C, let me move it over here. This has like first B and this where has K. So in this particular scenario, this will be lexicographically smallest. Okay, so what I'm thinking about is like after rearranging whatever we had ordered remaining, we might insert this particular substring. If we compare the first character from here, then just before that, because we can't go beyond this. Like we would never add this before an A, because A, like 4 times A will definitely be lexicography smallest than 3 times A. So we should definitely add it after the all the small characters which are smaller than the first character of this. Similarly, we will add it before the first character which we have from this, like C, because A, C will be lexicographically greater than like if we have one more B over here. So for example, if I add this, will be smaller than if I add this over here. Okay, so that makes sense. So ultimately, the problem statement is reduced to like inserting this particular pattern either over here or over here. Now, interestingly, where do we want to insert this pattern? Because, like, if depending on this pattern as well, the position might change a little. So let us say in this particular case, like where we have BK, we will like to insert it over here. But if we had BA, then we might have preferred this one because BA will actually be lexicography smaller than BB. Yeah. And is there anything else we would like to do? So, yeah. I don't think we would insert in betweens because that doesn't really make sense. Reason being, like, even if we take both the examples and try to insert, so if we do like this, something like this, and let me keep spaces so that it becomes a little easier for you to differentiate. So in this scenario, we would prefer this one, as in adding the string at the end, because like we would get 3 B's together, which will be lexicography smaller. And again, we would not add the string in this scenario in between as well, because over here we get 4A, then B, then A, whereas over here we get 4A's, then 2B's, then A. So, like with this statement, what I'm trying to explain is like kind of like narrowing down the approach that we have just 2 possible opportunities, like places where we would actually insert the string. Either it would be at the start of all the characters, the first character, what, whatever it is. Either we will insert the pattern in front of that or in the like at the end of that. If we don't have any of this like B's remaining, then we will simply add it in between, like A and C in between of that. Okay, this solution does make sense. Let's try implementing it. So string SMP, string SMP. Let me add a character map. Int count. Let's keep it 26. So basically, I will use like count of 0 refers to count of A and so on. Rep I comma 0 comma sorry, s dot length. What I have to do is count of what s of I minus. This is like a common trick to store character frequency. Let me do that, and from pattern, let me actually subtract that. So this is kind of now count at the end of this contains just the remaining values, remaining characters, whatever were present in S. Now, P can have length equal to S. Got it. So let me create two strings candidates S1 comma S2. Uh, I know like this is not really optimized. Like I just kind of assigning to S would not really make much of the difference of the overall complexity and will make my job easier because I can directly handle the indices now. So let me take the first character as well. Int first char of pattern. Definitely don't use this big variable name because this will increase the time which you take for implementing. I'm just like for the sake of better tutorial, I'm using this. Uh, P of 0. I hope the length is at least 1. Yeah. So now for all the characters which are less than this, I will definitely add it. For all the characters greater than this, I will add it later. So repeat I comma 0 comma s dot length int cur index equal to okay. So current index is basically like iterating over here, like on this count array. So while okay, let me actually make two so that this will be easier for me to implement. Count one, count two, this. Again, I think many of the times, if the overall complexity is similar, you can just focus on easier implementation rather than trying to have the best optimized solution. Like that's kind of the hack for CP. So what I will do is file. So I'm just trying to have the first candidate. First candidate is when I add the pattern before start of the first character from the pattern. While count one curve one is equal to 0, uh, curve one plus plus. So if there are like any zero things, like let's say there were no any A's and B's, it will skip that and directly come to C. There will definitely be one particular character from over here, and so curve one is less than 26, and just a check. So basically what I did was remove the front characters, and now if curve one is, I think I'm kind of complicating it. I do not need to complicate it so much. Let me just clean this up. In fact, let me just remove this altogether and int cur equal to 0 I comma 0 comma 26 int count equal to yeah. So basically, I need a plus I characters to have this many counts inside my string and anything else? No. So let me add a string saying string s uh, original. Call it sorted. So basically, when I initially discussed, uh, this was the remaining sorted remaining string. I will kind of append it to this and mm, is there anything else? No. So while let me actually make it to s so that it becomes easier for me. S dot substring 0 comma s dot length minus p dot length. So basically kind of like a random string I'm assigning it so that this has the exact length of the sorted remaining thing. This is not really the exact value which you want, but yeah, just kind of like have assigning it to a particular value. So while uh, so rep j comma 0 comma count. What I am doing right now is int first int 0 int last int equal to 0. So again, like in our original case, let's say the sorted remaining string is A, B, B, C, 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 and so on, and pattern is, let's say, starts with B, whatever it is. Then what I want to do is my first index should point over here, and my last index should point over here, right? Once this is done, I will simply insert, like have two different strings inserted them, and that should be good enough. So I do not really need multiple arrays. This should be good enough. Okay, so sorted string of cur plus plus equal to I plus a. This kind of gives you the sorted string. Let me actually print this right now so that this becomes much more easier for you to understand. Uh, mm, build failed. Okay, I don't really need this. Why can't I update this? Let me trace first. I don't know, it should not be an issue, right? Cur, comma, this dot length stop. Okay, this seems really weird. So I got the count. I think I made a mistake. What I have to set it as 0, right? I think I have this. Yeah, set one. Set one count, comma 0. Yeah, my bad. So basically remaining string has been updated. This should be good enough. So what I will do is I kind of update this, and if a plus I is less than the first character of pattern, then what I do is this is equal to cur, and over here what I will do is equal to, right? Uh, Let me add my use case as well. Input this aka uh, okay, let's make it 4. So AAA, BB, CCZ, uh, CCCC, and whatever. And my ultimate pattern is something like B, whatever. And just let me copy paste this as well. Yeah. So let's just run for the first test case for the time being. So sorted one is this, and let's see what are the values for first index and the last index as well. Last index should be this. So if a of I, which is actually a, and this first index will be, okay, it should be actually from over here. Yeah. So basically 0, 1, these are 6, right? So first index actually refers to this and last index refers to this. So I just simply have to insert the patterns over here and then see whatever is lexicographically smallest. So string candidate 1 is equal to sorted string dot substring starting from 0 and length becomes first of index. So that will be the first half of this plus whatever the pattern was plus dot substring which actually starts from first index. Okay, and similarly second candidate 2 is again something similar but from last, and if candidate 1 is greater than candidate 2, swap candidate 2, and ultimately let's just print candidate 1. Yeah. I think this should be good enough. 4. So in this particular use case, I had D, which should be at the end. And if I add one more test case as well, where it's A, like this should be inserted in the first one. Uh, BASAFS. Yep, totally what we expected. And just let me make it a little more complex. So if BBS, it actually should be inserted at the end. B BBSAF, right? Yeah, makes sense. Okay, and what about C? Just curious. It should again be at the end. B, yeah, makes sense. So yeah, I think this solution should be good enough. Let's try to submit it. Is there any particular corner case? I don't think so. Let's try submitting. Submit. Okay. Yeah, AC. Okay then, that's it for this problem. Thank you.